Okay, so just another quick introduction. So I'm Alex again, third year, doing CS, and I've been with the Biocomplexity Institute for a year now, so I've had a little bit of experience with this. I'm specifically going to be covering Ravana, but it's more or less the same as the CS cluster, and I'll get a little bit more into that. And if at any point there's any questions, you can go ahead and put them in the chat or speak up. Either one's fine. So starting right off the bat, why do we use SLURM? Why is it important? And what actually is SLURM? So when we look at Ravana, Ravana is actually a cluster of different nodes. So it has a collection of different CPUs, GPUs, memory. And in order to use these resources to run different jobs and tasks, we use SLURM to allocate those resources to different researchers. So some of the benefits of SLURM are that the researcher or the user can define exactly what resources they need for a specific task. They can say how many GPUs they need, they can say how much memory they need, they can do how many nodes they need, they can give it all these resources, and based off that, SLURM will add their specific job to the queue of jobs that needs to be run, and that way many different researchers can run jobs at the same time, only accessing the resources that they specifically need. So this makes it very usable because many people can use it at the same time. It also only allocates exactly the resources needed, and it allows teams to work in parallel because they can use different amounts of these resources. So kind of diving right into it, one of the most useful commands is SQ. So this just shows all the jobs that are pending or currently in the queue to be run. And it provides all sorts of different information about those jobs. So just to dive right into it, Ravana has this browser version where we can type commands straight into Ravana. So if I run SQ, I can actually see all the jobs that are currently on Ravana right now. So I can scroll up.
Hey, Alex.
Yeah.
I'm sorry to pause you. Could you please explain a bit about what do you mean by resource? Obviously, I know. I just want you to explain to others what are resources. What
Okay.
are the stuff?
Yeah, so sorry. So those resources, there's a lot of them, but I guess the biggest ones are, like I mentioned, the memory, GPU, and CPU. So you can specify maybe I need 10 different nodes because I'm running a lot of parallel jobs. I can
What do you
specify
mean by
that.
node? Oh, sorry.
Uh,
What do you mean by node?
Nodes are essentially different computers or different CPUs. I think I'm pretty sure that's the distinction. I guess you could classify node. That's what's meant by nodes, correct?
Yeah.
Okay.
One
Yeah.
node is that means that node be that node can be it can be one or two CPUs, can be multiple CPUs.
Yeah.
Uh,
I
it
think it just
depends.
depends. Yeah.
Yeah, it depends on how they build up that CPU.
Yeah. So
For
Ravana
example,
also. Sorry.
yeah. For example, um, the PC we are using. For example, if a PC, let's say, it has a Core i7 quad-core processor with 64 gigabyte of memory. So what does that mean? So it's a CPU. It can be considered as a node, okay? And for example, that single node can have two CPUs. Let's say it has two Intel Core i7 quad-core processor. So then it has two CPUs with quad-core processors. And if for example, if that processor has let's say 8 cores per CPUs, so that means as there are two CPUs, that means there will be 16 cores in total in a single node, right?
Yep.
So that's how we define what does resource means, and even you can define the memory as well, like how much memory is allocated for each course. Okay. For example, if it has let's say 64 gigabyte of memory, a gigabyte of memory, and if it has 8 cores, that means 8 cores ideally has the capacity of utilizing maximum 8 gigabyte of memory. So that's how the things are designed. Sorry to pause you. Go ahead,
No,
please.
no problem. And yeah, kind of going off of that. So Grafana is composed of all sorts of different CPUs and GPUs. It's a, I think if you look up on the website, you can kind of see that breakdown as well. So just looking at this SQ, we can see that there's kind of some variables that define each job. So the job ID, that's important. We'll get into some of these other things in a little bit, and then maybe the particular node that it's running on. So this is a lot because this is every single job, but you can pass in all sorts of, this zoom menu. You can pass in all sorts of different flags. So for example, if I only wanted to see the jobs that I was running, I can pass in this user flag, and I can pass in my computing ID or my user ID, and then this shows just the jobs that I'm running. Since I'm not running any jobs right now, it's blank. And I'll run a job in a second so you can see what that'll look like. So now for actually submitting jobs, how do we do that? We can do that with a SLURM script. It's essentially a shell script, and I'll show you what that'll look like in a second as well, with this sbatch command. So simply, sbatch just runs what's in the SLURM script. It kind of where you can define all sorts of different variables or directives, as well as the actual commands that you want to execute for the job. So kind of going into that, what does a SLURM script actually look like? So it's a shell script. For this one specifically, we'll use bash. So we can start with this hashtag bin bash to let it know that it's a bash script. And then all the directives or resources are going to have, or sorry, directives or variables are going to have this hashtag sbatch, and I'll show that on the next slide. But just as an overview, this is kind of where we're defining all those different resources. So like we were talking about earlier, the memory, it may be if it's using a GPU, how many nodes we're using, that type of stuff. And then as well as the actual command to run the particular script, maybe that you actually want. So kind of looking a little bit more at that, let's say specifically for the CPU, we want to allocate a specific number of tasks. This is what it actually looks like. I'll show that again in a second. This is kind of just, you can kind of understand what it looks like. Maybe we can allocate a certain number of CPUs, and same for memory allocation. Maybe we can allocate a certain amount of gigabytes of memory. And then this is another variable called wall time. So this is essentially the maximum limit on the time that the job is allowed to run for. And to kind of get a look at what that might look like, I have this script for you. I can zoom in a little bit. So you can see we start with that bin bash to let it know that it's a bash script. These are just some comments, but these are where we're defining these resources. So for example, if we look at this first line, we have this hashtag sbatch. We have this -n flag to let it know that we're specifically referring to nodes. I'll show you where to find all these different flags, so it's simple. But see here, we're declaring that we're only requesting one node. And here we're simply requesting that the wall clock or the timeout limit will be 48 hours. And you can see all these different variables. Here we're requesting 50 gigs of memory. This is the specific account we're using to where we're charging the job to, and all sorts of these different variables we're declaring. Additionally, I guess I'll remove that. But so additionally, at the end here of the file, we're actually doing all sorts of different commands. So we can start here. So when we first execute the script, we want to purge all the different modules that were loaded before. We want to make sure there's no modules loaded because we only want to load the modules that we need for this particular script. Here I'm loading PyTorch because that's what I'm using in this project. Singularity is simply a containerized application, so like Docker. We're not going to really dive too much into that. Just that's the simplest way to load PyTorch in. And specifically for all the different modules you need, I don't think you don't, sorry, you don't have to define explicitly every single module. For example, like you wouldn't have to do module load NumPy or module load pandas or all these things. So if they're already in your home directory, I believe they're just attached onto the into the environment. They're just loaded in automatically. I'm not sure. Is that correct, Arup?
Uh, Kinda. So let me explain a bit about that. Could you please go to that terminal window
Yeah.
you just added? Yeah. Okay. Perfect. The
So
thing is, like, whenever you want to use any frameworks, for example, PyTorch or Anaconda or any, say, let's say GCC versions or any Python versions, what you normally do in your PC, you either you can use you have to install it, right?
yeah.
From any kind of framework repos. It can be like either from pip or conda by using conda or simply apt-get, like apt-get install, let's say GCC. Okay, so these package repos basically have all those frameworks, and you have to install it before you use it. Um, but for any kind of supercomputing environments, first of all, they don't give you the root access. You cannot install any frameworks by using sudo or simply apt-get. So what they normally do is they install all the necessary frameworks as the module, okay, as a module. So that you don't need to install all those frameworks by yourself. And obviously, whenever you use any frameworks, you have to either you can use your base environment, which is currently Alex is using his base environment, okay, and from there you can basically see what are the modules are available and what are the modules you need. So Alex, can you execute module space list?
Sorry, what did you say? Module
List, list.
Okay,
Yeah. So basically there is no module is loaded. So Alex, can you do module space avail? Okay. So okay, see, these are the modules currently they have installed from different package sources. Okay, so if you want to use any module, for example, let's say you want to load GCC 9.3. Can you do that? GCC 9.0 module load GCC 9.3
it's
or
9.2.
9.2? Yeah, okay. You need to press enter. Enter. You need to press enter, okay. Enter, press enter. Yeah, okay.
So
This module load, let's say GCC 9. Yeah, you can just Control C and Control V. This will work here. Enter. So now module, now GCC 9.2 is loaded. Now perform module list. see this, these are the module that is currently loaded, but it is loaded into Alex default environments. So how do you know that which are the default environments? So what you can do is you can create new environment. That environment can be anything, like Python environment. That environment can be a Conda environment, which is a totally different topic. But yeah, that module is loaded into the default environment, and yeah, that's it. Yeah, go ahead, Alex.
Yeah, so continuing on.
And in that command you can load multiple modules, like Alex loaded Singularity and PyTorch at the same time. Two modules is basically loaded at the same time.
Yeah. So yeah, these are all comments, but here's where we actually run the script. So we run this Singularity. We're essentially going to pass in the current directory so that all the files in the directory can be accessed later on. This is simply a flag for GPU because we want to do this on GPUs. And then we simply run PyTorch on this train.py. So this is the script that I have that we're actually executing. And yeah, that's pretty much it. I think we can run this and see what that will look like. So to run it, simply we do sbatch, and then we type in the name of the SLURM file, and that submits the job. And now I can check my SQ, and I can see that I have this job running now.
Can you describe this SQ status, like job ID partition? What do you mean by partition?
Yeah, so this is so I'm running on the GPU partition because I'm using GPU. I think this is so kind of looking at all the fields, the job ID is a randomly assigned ID. This is how I can always refer to this specific job, so it's unique. So if I need to cancel it or if I need to view this job specifically, I can always type in this ID. And when you submit that, it'll tell you what that ID is. This is the name of the job. That's what I declared in the file. This is my user ID, so my computing ID. This is the time running. So if we run it again, oh, okay, it ended, but this will keep updating. We requested one node, so we're only using the node. And then this is the actual node that it's running on. And if we look at the file, we can see that I declared that the output file should be called output.txt. So now if we do an ls really quickly, we can see, I didn't do this before, but this file didn't exist before, but it's new. So now we can kind of view what that file may look like. This is just my machine learning. We got some accuracy. This is just the output of the code. So that'll work perfectly. So great. Now, if we want, so that job already ended, but let's say we were halfway through the job and we wanted to cancel the job for whatever reason, we can use scancel, and then you can type in the job ID that we were referring to earlier. So that just stops the job, and you can start all sorts of other jobs. One of the great things about SLURM is that maybe if you have multiple jobs or tasks that you need to do, you can run multiple of those, I think, depending on your account permissions. So if you have multiple things to do, you don't have to wait for one of those to finish. You can add all of them to the queue. Another way to run jobs is through Salic, or you can also use iJobs. So as opposed to giving all the information and all the commands in maybe like a SLURM file, we can run these jobs interactively. And what that means is we still allocate and we request these resources. So just as before, where we request a certain amount of nodes, we request a certain amount of memory, a certain amount of GPUs. We can request these nodes and then perform all sorts of different code or actions within a shell environment. So essentially, we can run whatever files we want. This is very useful for debugging, stepping through different code. That's what I've used it for. But most of the time you will still use SBatch, but it's still important to know about these iJobs or salad. A really good resource for an overview is if you look at their Ravana page, they have this run jobs using SLURM. So we click that. It's a very good overview of a lot of what I just talked about. It dives into a lot of different specifics. So if you ever need any help or guidance, this is a very good site to kind of base yourself off of. It also provides some like basic examples. But yeah, I think that more or less does it for a basic overview. So those three commands are probably the ones you're going to use the most. So sbatch, sq, and scancel, more so on sbatch and sq.
Hey, Lucas, can you prepare a small document for the CS cluster? Because, all the students have the access on the CS cluster, so they will use, and obviously you also use the CS cluster for basic experiment. So if they know, like, how slums work on CS cluster, and obviously this training is very good to give, like, what are the different parameters and stuff to do. But if you prefer a like or give some reference of CS clusters SLURM script, that would be nice. After this presentation, you can definitely share.
Yeah. Any questions or anything that was unclear?
Do you guys have any questions?
Yeah, could you like quickly go over scancel again?
Yeah, so maybe I could actually show you what it might look like. So let's say, so you saw in the queue when I ran this, you saw the job was active. If it's still active or if it's pending, we can cancel the job, and this just stops it where it is. So potentially, if we do we run the job, right, like this. So we have this job running. So if I run SQ, we can see it's running. So if we want to cancel it, we can just type the ID and this just stops the job. And you can see if we do the queue again, it just instantly stops. So if you, for whatever reason, the job's taking too long maybe, or you realize there was some bug and the output doesn't matter, or you need to stop it for whatever reason, you can always just cancel the current job. Yeah, so that'll just stop the output where it is currently. And yeah, that's pretty much it. So it's honestly, you won't be using it too often. You'll be using sbatch and SQ way more, but sometimes you need to stop a job for whatever reason. Maybe it's taking too long. Does that make sense?
Yeah, that was a good explanation. Thank you.
Okay, awesome. Any other questions?
So far, yeah. So far, that's a very good presentation, Alex. And obviously, my suggestion will be you guys should check how SLURM actually works. Even if you do any kind of projects or any program in your other class, then you can obviously use SLURM script to make your program more efficient. Like even if you want to execute a simple C program, with multi-processor or in a certain amount of memory allocation, you can do that. So even you can execute any Python program. So my suggestion will be like, check all the documentation that Alex shared and create a sample program and execute it and see how it works. Ultimately, we have to use SLURM script a lot to perform different Salon activities. Okay, that's all from my side. If you guys don't have any questions, we can stop today's session here. And yeah, let's meet in the next session. Okay.
Sounds good.
Yeah, that sounds really good. Also, Alex, I really enjoyed your presentation. I just want to
Thank
let you know that.
Awesome. Thank you.
Okay. Thank you, guys. Thank you for joining this call. Bye.
Bye-bye.
Thank you.
All right. Good night.
All right.